Oh, you came back. Thank you. Let's continue with our discussion on matrices. 8.4, matrices 3 by 3 and n by n's. Here we go. Right. Determinants of 3 by 3 and dun dun dun. Because we're going to do n by n's as well. But you are not going to be required to solve n by n cases on tests or assessments, okay? All right, here we go. 8.4, continuing. So now, we're going to use two different methods, and we're going to do one method first. It's called use minors and cofactors, okay? So we're going to first use minors and cofactors. So these are good definitions to know for your vocab, okay, for this chapter. Number 10, find the determinant of this matrix given. And this matrix is dun 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 dun. You're right, this is a square matrix, so it has a determinant. And it is a 3 by 3 matrix, okay? All right, so we're going to find the determinant of this 3 by 3 matrix. Now, a couple of setups before we start solving is this. Now, there's a couple of things. There's signs for cofactors, okay? So there's these signs, okay? So let's look at the sign patterns for cofactors. Now, always the A11 position, just have to remember that it always starts with a positive, and it alternates. Positive, negative, positive, negative, positive, negative, positive, negative, okay, and so forth. So again, even though it's a 4 by 4, it starts with positive, okay? A sub 1, always starts positive, and everything else alternates. Okay, that's all. It's a really simple rule that you have to remember. Again, so what about if it's an n by n matrix? What do you think, how do you think the signs will look like? Well, all you do is you always remember that you start A sub 1 with a positive sign. Okay, and then it just goes alternate signs. All right. Okay, so now these are, I'm going to tell you what the cofactors are, and I'm going to tell you what minors are. Okay. So look at this diagram here. Okay. Whoa, what is all this ABC mess, right? It looks like a mess, okay? Now, we're looking for the determinant of this matrix here. It was a 3 by 3 matrix, and it's got these elements here, and you can see that we're looking for determinants of a 3 by 3 because there are straight lines here. Now, remember this guy. So what cofactors are is we're going to choose a row or a column that's nice to work with. And you'll see what I mean by nice. Like you're gonna become so savvy at this that you're gonna know which row and column that you should use. But again, the first cofactor, A, so it looks like we're using A, B, C. That means we chose this row. So I'm gonna use a different pen. We're gonna use this row because this row must have been a nice row. Nice row. A thumbs up row. Okay? That's the row we're gonna use. But remember, this guy, the sign is always positive. That means this guy, whatever he is, maybe B is negative 2, maybe B is positive 2. It doesn't matter. We're going to put minus whatever B is and plus C because it goes plus, minus, plus. Plus, minus, plus. They just alternate signs. So if the cofactor here, if A equal 2, B equal negative 3, and C equal negative 4, here's what it would look like. This guy would be a positive 2. This guy would be minus whatever B is. B is negative 3, so you have to put it like this. And C is negative 4, but it's a plus, right? So you just put negative 4. So if it's a positive, it is what it is. And minus, you just change it. Try to understand that. If you don't, hey, pat your next door neighbor and ask them nicely, okay? All right, so let's move on and let's actually try finding the determinant of this guy here using minors and cofactors. Wait. If these are cofactors, what are minors? These little 2 by 2 matrices are minors. And what are these minors? And do you see, oh, you're a minor. I know that you're a minor, okay? Maybe some of you guys aren't, okay? But these minors are special. They're basically this. They're the 2 by 2 matrix that are formed if you take out the first row and first column that A is in. Look, A is here. If I take out that's what this thing is for. If I take out every row and column that A is in, I create a 2 by 2 matrix. And what I do is I find the determinant of this small minor determinant. Look at B. I take away every row and column that B is in. So I take away row and column that B is in. What am I left with? D, F, G, K. And that's the minor that I've created. You try for C. Take away, I cover up every row or column that C is in, then I'm left with this minor D, E, G, H, D, E, G, H. And what I do is I compute the determinant of that small 2 by 2 matrix. Okay? Rewind the video and watch it again if you did not hear me correctly, okay? That's the beauty of a video lesson. Here we go. Let's move on and let's actually calculate the determinant of this 3 by 3 matrix. Dun, 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 dun. So find the determinant of this matrix in two ways using minors and cofactors, because later we're going to learn how to find this in a different way, okay? Let's do that. Now, look at this. Take a look at this 3 by 3 matrix. Which row or column looks the most friendly for you to calculate with? I would agree with you. I think it's row 2. Now, sometimes I'm going to dictate which row or column that you have to use using minors and cofactors. But in this case, you have a choice. I think either row 1 or row 3 is also a good choice. But I think column 1 and column 3 are also good choices. But I'm going to tell you that we should use row 2 for this example. Let's do that. So we're going to do, what are we doing? We're looking for the determinant of this 3 by 3 matrix. Oh, sorry, that should be a 1 and 3, 0, 4. All right? Now, remember, minors and cofactors. That means this guy, I didn't choose this guy, right? Oh, wait, I didn't choose this guy. I chose this row. That means if this guy is A11 and he's always positive, it goes plus, negative, plus. This guy is a negative. That means my cofactor is a negative 1. Do you get that? It's a positive that we start with. So every element alternates signs. So if this is a positive, this guy is a negative. So I don't care that this is a positive 1. I'm going to make this a negative 1 and cover up every row or column that contains this negative 1. What am I left with? Oh, sorry, I'm using the wrong row. So I'm covering up this row here, right? This row here and this column here. What am I left with? 2, 3, 1, 4 is correct. So I'm going to make a minor 2, 3, 1, 4. That's a 2 by 2 matrix that I'm going to find the determinant for, which you know how to do. Now I'm going to go to the next guy. This guy here. This guy is negative. So I'm going to put this guy is negative, this guy is positive, this guy is negative. Because it all started with positive at the A11 position. So I'm going to go minus, and I'm going to put a negative 1 here for you. So you understand that better. Okay? So, yeah, this is a negative, this is a positive, right? So I'm going to do that. So negative, positive. Oh, so it's a positive. Sorry, plus. So it's a plus here because it goes negative plus negative. So positive here in the actual cofactor. And the minor of that guy, I remember I changed I'm going to use this marker to mark that. I'm going to cover up every row and column that contains the negative 1. So it's this guy and this guy. And what are you left with? 2, 3, 0, 4 is right. So it's negative 2, 3, 0, 4 is my next minor. Okay? Now let's go to my 0, right? My 0. My 0 is negative, right? So it's minus a 0. And I cover up every row and column that includes a 0. What are you left with? 1, negative 1. 1, negative 1, 0, 1, 1. 0, 1, right? And that's my, did I screw up somewhere? So I cover up the 0. Oh, sorry, guys. I'm sorry. So I should have put what? 2, I heard you guys yelling at me, okay? Negative 2, 2, 0, 1. That's my minor. Sorry about that. All right? So always, don't forget about the signage here, but also the minors. Now what I do, I take the negative 1, and I calculate the determinant of this guy. What is that guy going to be? 8 minus 3, because that's how you calculate the determinant of a 2 by 2 matrix, right? Minus, plus, I'll just put the plus negative 1 for now, okay? What's the determinant of this guy? It's negative 8 minus 0. How about here? Plus or negative, if you want, I'll just keep it as a negative here. Minus 0 times negative 2 minus a 0, right? So let's calculate further. The determinant of this matrix, let's call this guy A. So determinant of A is going to be negative 1 times 5. You can just calculate. You don't have to show me all this work, okay? I mean, let's actually not show the work because I think it's going to confuse you guys even more. Okay, so I'm going to erase this, okay? It's negative 1 times 5 minus negative 8, right? Minus a negative 8, correct? And it's minus or plus 0, okay? And what do you get? You actually end up with a positive 3 as a determinant of A. And that's how you calculate a 3 by 3 matrix using minors and cofactors, okay? So if we say minors and cofactors, find the determinant of a 3 by 3 matrix, you must do it this way where you have minors and you have cofactors, okay? All right, I'm going to show you now. There's an easier method. There's an easier method. Are you happy about that? The easier method is actually really, really simple. It's actually so simple. You're going to love it so much. Then here's how it goes. You use this really weird method, okay? So here's what you do. You have your original 3 by 3 matrix, okay? What you do is, when you're calculating the 3 by 3 matrix determinant, you rewrite it, and you copy the first 2 columns, just the first 2 columns right next to it. And then what do? You simply, sorry about the, sorry, it's not like focusing right now. Okay. Okay, there we go. All you do is you line them up and you simply multiply this diagonal, and this diagonal. And that's what I have here. That's the sum of these products. And I subtract the other diagonals. You see this diagonal here, CEG, AFH, BDI. But I always put this parentheses. So this one is going this direction, right? This direction. This guy is going this direction. So I always take all these and I add it up. I subtract all the ones that are going this direction. I know it's a really strange method, but it works great. And I'm sure you guys are thinking, thank God I don't have to use the cofactors and minors every time. So let's actually try that with the pretend that we just did. I know, you might have liked the minors and cofactors method, but I guarantee you not a lot of you guys will be using that method. I have a feeling, okay? So it's negative 2, 1, 0, 2, negative 1, 1, 3, 0, 4. What do? We write the first 2 columns again. Negative 2, 1, 0, 0. Right? Line it up nicely though, okay? Some of you guys have really messy handwriting. It might be hard for you. Let's see if we actually get the determinant value of 3. Okay, let's try that. Dun, 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 dun. Does it work? So determinant of A, let's multiply the greens going this way, right? Greens, okay? And remember, we're going to subtract the reds in a sec. So I'm going to do this. Negative 2 times negative 1 times 4, which is 2 times 4 is 8. Okay? And I'm going to go like this. And then let's try 2 times 0 times 0, right? What's 2 times 0 times 0? It's just 0, so add 0. What's 3 times 1 times 1? 3 times 1 times 1 is 3, okay? Minus, let's do the reds now. The reds go this direction, right? This way. I'm going to subtract out all these, okay? So I'm going to go 3 times negative 1 times 0 is 0. Negative 2 times 0 times 0 is 0. 2 times 1 times 4, so it's going to be 8. Okay, and what should that come out to be? The same as what we did last time with cofactors and minors. So it's 11 minus a whopping 8, which is 3. Yes, so determinant is 3. Yes, so do you like this method? Throw it up if you like this method. I like this method as well, okay? All right, so good luck with this method. So again, only 3 by 3s work this way, not 2 by 2 matrices. Only 3 by 3s work with this strange method. Now, before I go, I want to give you guys just a few more things, just some information, okay, about triangular and diagonal matrices. Now, part 3, triangular and diagonal matrices. It's very pretty simple, but they're scary looking, so you probably don't want to find determinants by hand, okay? Let's say, okay? Now, determinant is a product of all the diagonals in a triangular or a diagonal matrix. But you're wondering, what are triangular or diagonal matrices, right? So I'll give you an example. This is a triangular matrix. So is this. You see how the upper right is all zeros and the main diagonals and below has, so you see how all the lower values have values and all the upper values have values in this triangular matrix? So that would make this a triangular matrix. And all you do is you simply multiply 1, 3, 8 or 2, 4, 6 to find the determinant. So this guy is just 24. This guy would be 24, 48. Okay? That's how you do. Whenever you see a diagonal matrix or a triangular matrix, this is a triangular matrix because it doesn't have zeros all around, but it has it has values below on the left. So left triangular, upper right triangular matrix. Okay? So you just multiply the main diagonals. Now, what does a diagonal matrix look like? It's like this. It's when you have zeros everywhere else besides the main diagonal. And then in which case you also multiply simply the main diagonal. In this case, you get negative 14 for the diagonal. You don't need to do the whole, the whole method where you write the first 2 rows or first 2 columns or the minors and cofactors method for anything that's triangular or diagonal matrix, okay? All right, so I have some thinking questions for you, but I'll ask that in class, okay? All right, good luck, and make sure you get some practice on Schoology. There's your homework, but here it is really quickly, okay? Good luck!